Welcome to the video on how to export datasets from the Tygron platform for training a neural network to detect foliage. We will use a project that contains shapes of tree foliage. These are drawn as areas. We can inspect these by selecting areas in the ribbon bar. Unfold the foliage group and select the first area. Select the Attribute tab and verify that the foliage attribute has a value of 1. This value represents the classification number that will end up in the exported dataset. Fold the foliage group and select the Test and Train limit areas. Select the Attributes tab, and note that these areas are denoted with a Train limit area and Test limit area attribute. These will be used to split the foliage areas into two separate non-overlapping groups. Finally, select Overlays in the ribbon bar. And select the original satellite overlay. The foliage areas in this project were drawn on top of this satellite overlay that was rasterized with a grid cell size of 25 cm, which is shown in the detail panel. To train a mask RCNN model for detecting trees, we are required to export at least one train and one test dataset. Each dataset will consist of a set of foliage areas and corresponding satellite images, rasterized to masks and labeled with their classification. To export the foliage areas as an AI training dataset, hover over Areas in the ribbon bar and click on Export Geodata. We can keep the filter option on all. For the Format option, select AI Training Data PNG. With this option, the selected satellite overlay will be exported as PNG images. Next, check the box with Attribute. Click on the Select button and select the attribute named Foliage. Finally, check the Intersecting Areas box. For our train dataset, click on the Select button and select the attribute named Train Limit Area. Next, we will configure what way the dataset is generated. A dataset will be generated by moving an image window over the overlay of this project and rasterizing the intersecting areas within this window. The rasterized areas will be stored in a mask, and the attribute value will be stored in a label file. The image, mask, label and bounding box form a dataset entry, identified by a number. The image size is defined as a width and height in grid cells, and can be increased. When adjusting the image size, remember that the number of areas within the image may not exceed 250. We will use the default image size of 200 by 200. For the overlay option, select the original satellite. It is important to keep these the same for the train and test datasets. Stride is the amount of movement on the grid to the next image. To ensure all areas are properly interpreted, it is best to have the images overlap each other, in this case 50%. You can keep this setting for now. Now click on Export Files. You will be prompted for a folder name. Best is to create a new empty folder for the export. In case the folder is not empty, a confirmation pop-up appears to overwrite conflicting contents of that folder. Create a new folder to save the files to. We advise exporting train data under a project folder within a parent train folder. To export the test dataset, you can repeat these steps, but instead of using the intersecting areas attribute train limit area, use the attribute test limit area. Also save the test dataset to a separate new folder. Similarly, export the test dataset under a project folder within a parent test folder. This way the datasets are properly separated, making it easy to specify a main train and test folder when training a PyTorch model. As you can see, an exported dataset is a collection of images, masks, label and bounding box files, where each data entry is identified with a specific number. You have now learned how to export a train and test dataset that can be used to train a PyTorch model. In the next video you will learn how to train a PyTorch model by setting up a specialized Tygron environment that creates an Onyx file that you can subsequently use in an AI inference overlay.